Welcome to Archicraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dima Golodiuk at demongo.com.
You're listening to the very first episode of the podcast. This episode is titled, Why Your UI is a Deep Architectural Decision. In this episode, we explore why your choice of user interface is one of the most profound architectural decisions you can make, arguing that UIs are not merely a superficial layer, but are foundational to your entire system design. Let's get started.
Welcome to the deep dive. For a long time, user interfaces, UIs, they've kind of been seen as just the pretty face of a system, right? Like a superficial layer you just sort of tack on at the end. But what if that whole idea is just wrong? What if the UI is actually a really deep, fundamental architectural choice?
Yeah, that simplification, thinking of the UI as just a presentation layer, it's really common. But honestly, from an architecture perspective, it's kind of dangerous. The second you pick a UI approach, maybe it's a command prompt, maybe it's waving your hand that choice. It's like signing a contract. It profoundly dictates your back end, how data moves, security, scaling, even how easy it is to maintain down the road. It's really the main agreement between the system and whoever's using it.
Okay, so that's our mission for this deep dive then. We're going to unpack the whole spectrum, CLI, TUI, GUI, VUI, NUI. We'll look at them not just as design choices, but as foundational architectural decisions, and really stress how important solution architects and enterprise architects are in making these calls up front.
Absolutely. It's critical.
All right, let's start with something that might feel a bit old school, but is still super powerful, especially for IT folks like us. Text interfaces, CLIs, and TUIs.
You're absolutely right. They're not relics at all. They are essential tools, and they come straight from that classic Unix philosophy. Simplicity, modularity, composability, and those ideas. Still incredibly relevant for the complex distributed systems we build today.
Yeah, it makes sense. And CLIs, command line interfaces, people often call them the quintessential embodiment of that philosophy, or even an API's best client. What gives them that architectural strength?
It really comes down to their, meticulous design. Think about the structure. You've got commands, arguments, and flags. A good CLI often follows a pattern, maybe like group resource operation. And architecturally, there's a strong preference for named flags, like output JSON, instead of just positional arguments.
Okay. Why is that?
Because named flags give you context. They make scripts easier to read, less likely for someone to mess up, and way more resilient if the command order changes later. That robustness is gold for automation.
Right, so you're not trying to remember, was that the third argument or the fourth?
Yeah.
Some long script.
Exactly. Then there's the strict separation of I/O streams, stop for normal output, stir for errors and warnings. Architecturally, a well-behaved CLI only puts its main data on start. Errors go to stir. This discipline is what makes piping reliable. Your next command gets clean data, not junk mixed with error messages.
Okay.
And finally, exit codes. Crucial for automation. 0 means success, full stop. Anything else signals some kind of failure. CI/CD pipeline scripts, they rely on this to know if things worked or broke. It builds really solid automation.
That rigor, that structure, that explains why CLIs are just indispensable in the enterprise. They're the language of automation, aren't they? You can version control the commands, run them in pipelines. That's basically GitOps, right? Managing everything through Git, super powerful.
And think about the cloud and containers now. Most resources are headless, no screen attached. CLIs are often the only practical way to manage them over SSH, especially if your connection is slow. A GUI just wouldn't work well.
Yeah, definitely. And for developers, tools for AWS, Kubernetes, GitHub, the CLI is often the main interface. You get that fine-grained control, that speed, you just can't match with the GUI sometimes. But CLIs are usually one command, one response. What if you need something more? Continuous, more interactive, but still in the terminal. That's where TUIs come in, right? Text-based user interfaces.
Absolutely. They carve out their own architectural space. The key difference, architecturally speaking, is state. A CLI is mostly stateless command response. Done. A TUI, though, it's a stateful application. It takes over your terminal window and draws interactive widgets using text characters. Think dashboards. You choose a TUI when an expert user needs to see a lot of interactive data, densely packed, but within the limits and efficiency of a terminal.
So it's like a middle ground.
Yeah.
More interactive than a CLI, less resource hungry than a full GUI. What are the big architectural pluses?
Well, first, resource efficiency, like you said. You get a rich feel without the CPU and memory hit of graphics. Second, keyboard-centric workflow. They're built for speed for power users who live on the keyboard. And third, just like CLIs, superior remotability. They work incredibly well over laggy SSH connections where trying to use a remote GUI would just be painful.
That makes perfect sense when you see tools like K9s for Kubernetes or HTOP, real-time monitoring without bogging things down.
Exactly. And you also see them in embedded systems, installers. Think configuring a network switch or installing Linux. They give you interactivity where a full GUI might be too much or just impossible.
Okay, so from these precise text-based worlds, let's switch gears. Let's talk about the most common one, the GUI. Graphical User Interface. They're user-friendly, sure, but they bring this huge challenge for architects, don't they? Managing all that visual complexity so it doesn't become a maintenance nightmare.
Oh, absolutely. And that's precisely why we have architectural patterns like MVC, MVP, and MVVM. They didn't just appear. They evolved specifically to tackle that complexity. They're all about separating concerns to keep GUI applications maintainable, testable, and able to scale. The whole story is about finding better ways to decouple things.
Right. So Model View Controller, MVC, that was kind of the starting point, the first big idea for separation.
Yeah, it introduced that crucial split. You have the model for data and business rules, totally unaware of the UI. The view shows the data, and the controller is the go-between, handles input, updates the model, tells the view what to change. Groundbreaking stuff, but the classic architectural trap was the massive view controller. Controllers just got huge, full of logic, hard to test separately, and really tied to the specific UI framework you were using.
Yeah, I've seen that movie before. So how did Model View Presenter, MVP, try to fix the testing problem specifically?
MVP basically said, look, your presentation logic needs to be as separate from the visual bits as your business logic is from the database. The big shift architecturally is the view becomes totally passive. Like really passive, just a dumb display that passes user actions to the presenter. All the smarts move to the presenter. It holds the presentation logic, talks to the model, and then tells the view exactly what to show, usually through an interface contract.
Okay, so the presenter is running the show for the UI logic. What's the huge win there for architects?
Testability. The presenter is just plain code, no UI framework dependencies. You can unit test it easily. That's massive for teams serious about quality and automated testing. The trade-off, architecturally, can be more boilerplate code because you have to define those interfaces between the view and presenter.
Right, those interface definitions add up. Which brings us to Model View, View Model, or MVVM. That seems to be the go-to now, leveraging data binding in modern frameworks. How did it tackle that boilerplate issue?
MVVM introduces the view model. Think of it as an abstraction of the view's state and behavior. The model is still the same. The view is mostly declarative markup, very little code. The view model exposes properties like data to display and commands, like actions the user can trigger. Crucially, the view model doesn't know about the view directly. The magic, architecturally, is the binder. It's part of the UI framework, and it automatically syncs data between the view and the view model. View model property changes, the UI updates, user types in a box, the view model property updates automatically.
That automatic syncing sounds like it cuts out a ton of manual wiring code.
It does. That's the profound architectural advantage. Way less glue code. The view model stays clean, independent, super testable. It's why patterns like this are standard in frameworks like Angular, Vue.js, .NET MAUI, especially for complex reactive UIs that handle lots of data.
So looking back at MVC, MVP, MVVM, it's a journey, right? MVC had the fat controller problem. MVP fixed testability by separating view presenter, but added interface boilerplate. MVVM uses data binding to get clean separation and reduce that glue code.
That's a great summary. Each pattern hits a sweet spot architecturally. MVC for maybe simpler things, MVP for testability when you don't have binding, and MVVM for modern data-heavy reactive UIs. Understanding those trade-offs, coupling testability, benefits, drawbacks, that's the architect's job.
Okay, let's totally shift gears now. Let's talk about interfaces that feel Well, effortless. But underneath, the architecture is incredibly complex. Voice and natural interactions, VUI and NUI. It almost breaks my brain thinking about all the steps between me saying, Alexa, play some jazz,
Yeah.
and jazz actually playing. Can you break down that hidden architecture?
Yeah, it's fascinating. The first thing to grasp is that VUIs and NUIs are essentially thin clients. All the heavy lifting happens in these massive, real-time, AI-powered back-end pipelines. The simplicity you experience hides huge server-side complexity. For voice, a VUI, it starts right on your device with a wake word detection, that little chip that's always listening for Alexa or Hey Google. It's low power on device, crucial for privacy. Once it hears the wake word, your speech streams up to the cloud for automatic speech recognition, ASR. This takes the audio and turns it into text. It's computationally heavy stuff.
Okay, audio to text. Then the AI kicks in.
Exactly. The text hits the natural language understanding NLU engine. This is the AI core. It figures out your intent, what you actually want to do, and pulls out the entities, the parameters. Like in the book a flight to Boston, intent is book flight, entity is destination, Boston. Next up is the dialogue manager and state management. This piece orchestrates the whole conversation. It takes the intent, decides what to do next, and really importantly, keeps track of the context if it's a back and forth conversation. That's state management, a major architectural headache, often involving complex state machine logic.
Wow, so it remembers the conversation, not just the last thing I said. That's impressive for something spread across different services.
It is. Then, to actually do the thing, the dialogue manager handles business logic integration. It calls out to other backend systems via APIs, flight booking systems, music services, whatever. Finally, the system figures out a text response, sends it to a text-to-speech TTS engine, like the one we're preparing this for, which creates that natural-sounding voice reply. The biggest architectural hurdles for VUIs: latency because of all those cloud round trips, and state management keeping track of the conversation in a distributed, often stateless environment.
That is a lot going on behind that simple voice command. Okay, what about NUIs? Natural user interfaces.
Yeah.
Gestures, body movement, that kind of thing. What's the architectural complexity hiding there?
NUIs are similar in that they rely on a complex real-time pipeline, but is focused on interpreting physical actions from sensor data. It starts with the sensor layer cameras, depth sensors like Kinect used to have, accelerometers in your phone or watch. They capture raw data about the physical world. That raw data goes into a data processing and fusion pipeline. This is where data from different sensors gets synced up and merged, like lining up the color image with the depth data to understand shapes and motion better. This often needs serious processing power, sometimes right on the device or at the edge.
Okay, so it cleans up and combines the sensor input. How does it figure out what I'm doing? Like waving my hand?
That's the job of the recognition engine. It uses specialized machine learning models trained to interpret specific actions from that processed sensor data, classifying a hand wave, a pointing gesture, maybe even recognizing body posture. Once an action is classified, the application logic gets triggered, calling the right function in the system. And just as important, there has to be a feedback mechanism, visual, sound, maybe a vibration, to instantly tell you, the user, yep, I saw that gesture and I'm doing the thing. Closes the loop. The defining architectural challenges for NUIs are tough. Real-time processing, it has to feel instantaneous, and handling environmental variability. Think changing lights, background clutter. The system has to be robust enough to work reliably despite that noise, which puts huge demands on the ML models and the pipeline.
Wow. Okay, we've gone from the command line through GUIs and their patterns all the way to these complex AI pipelines for voice and gestures. So let's bring it all together. For an architect facing a new project, thinking about the UI, how do you actually choose the right one? What's the playbook here?
Yeah, that's the critical question. And the absolute key takeaway is there is no single best interface. It's always, always a strategic trade-off. Architects have to weigh things up across several critical dimensions.
Okay, what are those dimensions you're balancing?
Well, first, the architectural profile. Is this UI basically an API client, like a CLI? Or is it a complex distributed system, like a VUI and UI? That has huge implications. Then, resource consumption. CLI to UI are super light. GUIs are heavier on the client. VUI and UI are light on the client, but massive on the back end. Maintainability and total cost of ownership, TCO.
Yeah.
Text interfaces, generally low TCO. GUIs, moderate, .VUI and UI. Very high because of the AI complexity, ongoing model training, etc. We also look hard at the primary testability challenge. For CLIs, it's script compatibility. For GUIs, it's those flaky end-to-end UI tests. For VUIs, it's the sheer variability of human speech, accents, noise, phrasing.
Makes sense. And security must be a big one, too.
Oh, absolutely critical. Key security risks. CLIs worry about command injection. GUIs face the classic web stuff, OWASP popped in, like cross-site scripting, VUIs and NUIs. Big concerns around data privacy, maybe eavesdropping, plus new threats like adversarial ML attacks designed to fool the AI. These are all major architectural considerations.
So putting all those dimensions together leads you to some kind of UI selection matrix, where maybe the main factors are who the user is and what they're doing.
Exactly. It often boils down to two main axes: the expertise of the target user and the application's domain or context. Are we building for novices who need things to be obvious and easy to learn? That pushes you towards GUIs. Or are we building for experts who value speed and control above all and are willing to learn a CLI or TUI to get huge productivity boosts?
Right. Can you give some concrete examples from that kind of matrix?
Sure. Take cloud infrastructure management. The recommendation is almost always CLI TUI. Why? Automation, remote access, scriptability are king for developers and SREs. They want control and efficiency, low TCO.
Okay. What about an internal CRM or ERP system?
That's going to be a GUI, probably web-based. You've got tons of data, complex workflows, and crucially, users who are business folks, not necessarily tech experts. Discoverability is key.
An e-commerce website.
GUI again, web or mobile. You need maximum accessibility for the general public. Visual presentation sells products. Low barrier to entry.
How about an in-car infotainment system? That's a really specific context.
Yeah, there you often see VUI plus GUI multimodal. Safety demands hands-free, so voice handles common commands. The GUI provides visual feedback, maps, and handles more complex settings when parked.
Interesting. What about something really specialized, like a surgical augmented reality AR system?
That screams NUI gesture, maybe gaze control. The surgeon needs sterile, hands-free interaction with 3D overlays during a procedure. Gestures are way more intuitive there than voice or trying to use a keyboard.
One more: warehouse inventory management.
Often a VUI, maybe paired with a rugged mobile GUI. Hands-free voice can make tasks like stock checking much faster. The mobile GUI is a fallback, good for visual confirmation or more complex lookups. It's about optimizing for task-oriented workers in that specific environment.
This has been fantastic, really peeling back the layers on these different UIs and showing they're not just surface choices. It absolutely drives home that picking a UI is a deep architectural decision with consequences for the whole system.
Definitely. And if I had one final thought, it's that the future isn't really about one UI paradigm taking over. It's about smart integration, multimodal interfaces. Think about asking your voice assistant to pull up sales data, seeing a chart pop up on your screen, GUI, and then using touch gestures, NUI, to zoom in and explore it. Architecturally, that needs really sophisticated event-driven systems behind the scenes.
So big companies will need a whole portfolio of UIs working together.
Exactly. A single enterprise might have a CLI for its core APIs, a web GUI for customers, a mobile GUI for employees, maybe a VUI for field support. And even in this complex world, those old Unix ideas, simplicity, modularity, composability, they're still incredibly good guides. Do one thing well applies just as much to a microservice handling NLU as it does to grep. The architect's job is to understand all these trade-offs and weave together the right interaction modes for the job.
A really powerful way to think about it. So for everyone listening, as you approach your next project, maybe ask yourself, how will you apply these architectural insights? Are you making sure you choose the right interface for the real needs, not just settling for the easiest one or the one that just looks the prettiest?
Thanks for tuning in to Archicraft. This episode was generated using AI from Dmitro Golodiuk's blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.